Bismillahirrahmanirrahim. Dear viewers, today we will see how to design pile cap in SAFE. We will use SAFE version 20.2. For example, column width along x direction 0.4 meter, that means 40 centimeter. Column depth is along y direction 0.8 meter, that means 80 centimeter. We can provide input in imperial unit. Unit will be changed here, and we have to provide the input data accordingly. I will go with SI unit. Rebar strength we will consider 415 MPa. Concrete strength F prime C 25 MPa. Modulus of elasticity of concrete EC equal to 4700 into square root of F prime C in SI unit. Now we will come to pile data. We will get this pile data from soil report. For example, we are considering pile diameter 600 mm. From soil report, the pile capacity is 600 kilonewton. Length of pile L 15 meter, that means 15,000 mm. Now we will provide load data from analysis result. Axial load along vertical direction 2300 kilonewton. Moment along x direction for lateral load along y direction mx equal to 95 kilonewton meter. Moment along y direction for lateral load along x direction is 78 kilonewton. This data we will get from analysis result. Now we will calculate point spring. We know that point spring K equal to EA by L, where E equal to modulus of elasticity, A equal to cross sectional area of pile, and L equal to length of pile. From the calculation we are getting this value in Newton per millimeter unit. Converting this unit into kip by inch, we will get this value. Spring constant along horizontal direction, this one kV equal to vertical direction, that means along z axis. K is along x and y axis. This is 10% of vertical point spring. Now required number of pile for this pile cap 4.6. Provide number of pile, round up this number, so this is coming 5. The equation to calculate number of pile is here. We have provided the equation, this one, in pile equal to 1.15 into total load on column divided by allowable load or pile capacity. This 1.15 we are multiplying to consider the self weight of pile cap, and here this one additional factor coming for the additional moment mx and my. Here we can see ex equal to my by f, ey equal to mx by f. So from this equation, required number of pile is 4.6, and round up this figure, it is coming 5. Now we have to select the pile type from soil report, whether it is friction pile, in bearing pile, or pile rested on rock. Depending on this pile type, our spacing will be changed. For friction pile, this spacing will be 3 into pile diameter. For in bearing pile, the spacing will be 2.5 into pile diameter, and for pile rested on rock, this spacing will be 2 into pile diameter. So spacing of pile is coming 1.8 meter, and edge distance is coming 900 millimeter, considering 1.5 into pile diameter. This one we can consider 1.0 into pile diameter to 1.5 into pile diameter. If I consider 1D, then here we will change the factor 1.0 into D. Here I am going with 1.5 D. We have calculated point spring, number of pile, and the spacing and edge distance of pile for modeling pile cap. Now we will go to SAFE software. Open the program, go to new model, metric SI unit. region United States. Design code we will continue with ACI 31814. Click on OK. We can use grids to model our file cap, or we can use DXF file to model our file cap. Here I will import the DXF file. I will start with blank, this one, save this one. Now go to AutoCAD, draw file. If we consider this CAD file unit in millimeter, we have to draw the file diameter in millimeter, 300 millimeter radius, so it will come 600 millimeter dia. We will put another file along 45-degree angle, so here draw this line at 45-degree angle. Here we can see this distance and angle. Here editing option in distance. If we press on tab, it will change the editing option to angle. Now I will type 45, enter. Now I will provide the file spacing. I will draw a circle with file spacing distance 1800. This one. I will extend this line to here. Now I will copy this file to here. Now this file I will make it mirror, then these two file again mirror, like this. So this 5 file we have got, having the spacing with center file 1800 millimeter. Now I will take a rectangle from this point to this point, as our edge distance from external file center is 900 millimeter. So I will take offset O, enter 900, enter, like this. Now this is our file cap with 5 files. I want to separate the layers. New layer, PC, file cap, color. I will take this red. Now this, change the layer, file cap. In these files we'll select and change the layer to file. Now I will draw the column at the center of file cap. This column size is 40 centimeter by 80 centimeter, so 400 by 800. This one I will move here. Change this layer to column. Now I will draw some points. Point, enter, in the center of files. Okay, this point is looking very small. You can change point style, P type, enter. Here we can change the style like this. type this font size you can reduce 2%. Okay, like this. Now this point also you can change the layer. Now save this one. Save as DXF file. Okay, now close this one. Now I will import CAD drawing unit millimeter. Now we will define material properties. Add new material. I will choose Indian region to get concrete material M25, that means A prime C 25 MPa. Click on OK. OK. Add new materials. Rebar 415 MPa. Click on OK. OK. Define rebar sizes. We will use metric bar in SI unit. SI. Click on OK. Now define section, slab section. Modify this one. File cap M25. Shell thick. We will use matte for file cap. 800 millimeter thickness. Click on OK. Add copy column M25 thick, and this one will be stiff 800 millimeter thickness, same thickness of file cap. If we increase the file cap thickness, we have to increase the column thickness for this stiff type. If file cap thickness is 900, here it will be 900. Click on OK. Now add copy for file, thickness same 800 millimeter. We can change the color. This one column file cap red, file this one. Okay. Okay. Now we can go to display, architectural layer, file cap, this one, add area object. We can see the properties, property section property none. We will change it PC file cap 800. Click on OK. Now we will turn off the architectural layer. Again we will import that DXF file for point object. In this time we will import DXF file of floor plan in this option. Open. Provided point layer, this one as point, DXF file unit millimeter. Click on OK. It will ask again the file to be saved. Save this one. Now the points have been imported. For these points we will draw grids. Go to edit, add grid lines, add selected, joints parallel to x and y. Okay, also these points. Previous selection, edit, add grids, click on apply. Okay. You can modify grids. Now this is perfect. Now we will draw our piles. Circular pile, diameter 600, 600, 600, 600, 600 and 600. Now change this to rectangular, column 400 by 800. Yeah, like this. Now we will define point spring. Add new. This one, here it is in kilonewton meter. In our Excel we have got Newton per millimeter. So here first we can apply load in kilonewton meter. Here 2300 kilonewton. Select the point, assign joint load force along z direction minus 2300 mx 95 my 78. Size of load for punching shear calculation. This size will be same as the column dimension, 400 by 800. Here we are applying the total gravitational load in dead load pattern. If we want to apply the gravitational load pattern separately in dead load and live load, we can do that one. But here, to simplify the procedure, we are applying the gravitational load in dead load pattern, and for design of pile cap we will provide the factor 1.5. If we apply the load in separate load pattern, dead load and live load, then we will provide the design load factor 1.4 for dead load and 1.6 for live load. Here we are going with only single load pattern. Apply, close. Now we will change unit to define our point spring for pile. Newton. We may have a question why we are defining point spring. We have to calculate point spring to provide the data of pile length, modulus of elasticity and cross-sectional area of pile in that point. So go to define point spring, add new property, this one Z, that means here kV, here it is coming, this one copy, here we can paste as number, then copy over there as paste. This one we can copy here and we can multiply by 0.1 to consider 10% of vertical point spring stiffness. 0.1. Now this value copy here. Okay, it's compression only. Click OK. Okay. Now the pile joint will be selected, then go to assign joint spring. We can see in different colors like this. Now we can define load combination, add new, here ultimate, that means design, load factor will be 1.5, add copy for serviceability to check the displacement or other thing, factor will be 1. Click on OK. OK. Now select the file cap, assign shell, floor auto-mesh option, here 1000 millimeter, or we can make it more smaller, 500 millimeter. Now we will draw the strip manually using this option, or we can go to edit, add or edit design strip, add design strips using grid. Here 500, so total strip width 1000 millimeter. In this strip we will get the number of river. From that number we can calculate the spacing of the rivers. This is showing the strip width. We can turn on this using this option, design strip object, show width. We can draw middle strip also. Left 0, right 500, left 0, right 500. Here to here, right click, five hundred, 0, 500, 0. Like this. Now we have drawn our design strip. Now we will go for analysis and design. Before going to that, we will check the preference. Minimum cover 50, bottom 75, preferred bar size 20, so only for slab. This is okay. Design code, this one, click on OK. Then select the design combination. For design, click on OK. Run analysis and design. Here it is showing the displacement for dead load 1.452 millimeter. We will check punching. This one 0.42, 0.443, 0.483. So this is below 1. So for punching, the pile cap thickness is okay. You can see in 3D view. You will see the reaction for serviceability. Change the unit, kilonewton meter. Here we can see the load on pile 542,505. Our pile capacity is 600 kilonewton. Here at the center, the pile reaction is coming 643. So at center, in this case, we can increase the center pile capacity by increasing its length or increasing its diameter, or we can increase the number of piles to reduce the reaction load on this pile. Now I will show the reinforcement design. Go to plan. Here we can see strip forces for design. This is the strip forces. Layer A, layer B, this one. We can see the reinforcement design. Impose minimum reinforcing and show number of bar size. Top bar I will select 16 mm die bar, bottom 20 mm. Click on apply. Here along rebar along x direction, maximum rebar at top 816. Here we can see maximum at top 816, maximum bottom 720. So top 816, bottom 720. Here we can check our strip width is 1000 mm. For bottom we have selected 20 mm. Number of bar shown in safe in the strip 720. So spacing coming 166. We can provide bottom 160 mm center to center or 150. And for top we have got 8 number of bar 16. This rebar spacing is coming 142. So we can provide 140 mm center to center. So here x direction rebar design details we have got. Along y direction we will check for layer B. Here you can see top 816, bottom 520. Here you can see 520. So along y direction we can make it 16 millimeter dia bar for bottom, apply, then it is coming 816 at top and 816 at bottom. So here 816 means 140. So for y direction we will provide 16 millimeter dia bar at 140 millimeter spacing at bottom and 140 millimeter for top. So this is our rebar design for pile cap. We can generate design report, file, create report. Here all the input data and analysis and design result will be shown. You can see punching, share, design, punching share data 6.8. Here you can see 5.5679. These 5 points of file. Here the punching ratio 0.42, 0.44, 0.362, 0.482, 0.49. Status is okay. Combination ultimate design. In this report we get print. We can get details drawing in safe also. Here before running detailing you can go for view detailing preference. Before running the detailing, here go to matte, here edit reverse selection, the smallest bar 16, largest 28, preferred 16, minimum spacing, here it is in meter, 0.1, 0.1, maximum spacing 0.2, 0.2, click on OK. Now run the detailing. Layer A, here 16 millimeter at 140 millimeter center to center. At center 16 millimeter dia at 140 millimeter center to center. You can see the rebar strip view. We can see 3D view for rebars. Here it is showing the rebars from design, not enforcing the minimum rebar. In this way we can model pile cap. We can do analysis and design of pile cap in safe. So thanks for watching. Stay tuned for more upcoming important tutorials.
Press the bell icon on the YouTube app and never miss another update.